You know, every few decades, we get hit with a tectonic shift in technology, a moment that literally redefines how we interact with our computers. Think about the jump from typing out commands on a black screen to clicking around a graphical desktop, or, the birth of the modern smartphone. Well, we're standing right at the threshold of another one of those massive historical milestones today. Welcome to this explainer. We're going to completely unpack the architecture, the capabilities, and honestly, the sheer ambition of NVIDIA's newly announced RTX Spark. This isn't just your standard yearly chip upgrade. We are looking at a ground-up reimagining of the personal computer.
Think about what NVIDIA's CEO Jensen Huang said during the May 2016 announcement, because it really hits the nail on the head. He pointed out that for 40 years, we've launched apps. Click, type, repeat. But with RTX Spark and Microsoft Windows, you just ask, and the PC actually does the work. That dynamic completely flips. The burden of execution is no longer on us. It's basically the absolute end of the traditional app launching era.
So to really get why this is such a huge leap, we have to look at the foundation. The traditional PC, the x86 architecture we all know, is totally app-centric. It's a passive tool. It literally just sits there waiting for your explicit instructions before it does anything. But the RTX Spark, it shifts us into an agentic AI PC model. By moving to this super efficient ARM-based architecture, your computer goes from being that passive tool waiting for clicks into a proactive teammate that securely runs autonomous AI agents right in the background.
Now, to pull off that kind of local autonomy, you need a mind-boggling amount of raw power, and the RTX Spark absolutely delivers. We're talking 1 petaflop of AI compute. 1 petaflop. That is 1 quadrillion operations per second. To put that into perspective, we are talking about literal server-grade artificial intelligence muscle packed directly into a standard laptop chassis. There is just no precedent for this kind of spec in a consumer device.
Here's our roadmap for today's explainer. First, inside the Superchip. Second, the Blackwell architecture. Third, the era of personal agents. And finally, next-gen gaming and creation.
All right, Section 1. Inside the Superchip, a paradigm shift in silicon.
To actually make this massive performance leap physically work inside a thin, light laptop, NVIDIA teamed up with MediaTek to build a system on a chip using TSMC's 3nm manufacturing process. It's kind of like a super pizza. Instead of having your CPU and GPU sitting on completely different parts of the motherboard, everything is baked into one highly efficient package. Your 20-core ARM-Grace CPU, that's the cross, the absolutely massive Blackwell GPU with its 6,144 CUDA cores, those are your premium toppings. But the real magic is the unified memory, the cheese that holds it all together. You've got up to 128 gigabytes of LPDDR5X memory that both the CPU and GPU can access instantly thanks to a lightning-fast NVLink C2C interconnect.
And because that memory is instantly accessible across the whole chip at 300 gigabytes per second, you get zero bottlenecking. The data just flows. Plus, this entire package operates at a maximum thermal design power of just 80 watts. So what does that mean for you? It means you get incredible desktop-level performance, but your battery actually lasts all day, and the laptop stays surprisingly cool even when you're pushing it to the absolute limit. Moving on to Section 2, the Blackwell architecture, neural rendering at the core.
Tracing the evolution of NVIDIA's tensor cores, you can see the path from Pascal all the way up to the new 5th generation inside Blackwell. The absolute game changer here is the jump to FP4 precision. As generative AI models just keep exploding in size, FP4 lets these tensor cores crunch through massive neural networks incredibly fast. It's what makes it actually possible to run these heavyweight AI models completely on your device without ever needing to connect to the cloud.
But it's not just about AI. We also have 192 4th-generation RT cores dedicated solely to ray tracing. These cores pack new intersection engines that pull off some unbelievable physical accuracy. We're talking real-time lighting, perfect shadows, and insanely complex geometry that makes virtual worlds look almost exactly like physical reality. And it does all of this while generating pixels at a fraction of the computational cost we're used to.
Now, to manage all that power efficiently, Blackwell features the biggest overhaul to its clock architecture in over 10 years. In older generations, clock speeds were basically locked in while a frame was generating, but Blackwell uses accelerated frequency switching. It can adjust to dynamic workloads 1,000 times faster than before. It ramps clock speeds up or drops them down almost instantly, which perfectly balances raw performance with power efficiency exactly when you need it.
So what do all these micro-level silicon upgrades actually mean for you in the real world? Well, with the RTX Spark, you can locally run 120 billion parameter large language models with a 1 million token context window. Just think about that for a second. You are running massive, state-of-the-art, open-source AI models natively right on your laptop. You can process huge amounts of data instantly, entirely offline.
Which brings us to Section 3, the era of personal agents, from tool to teammate.
When we zoom out to the operating system level,
The whole point of the RTX Spark is to power personal AI agents. But let's be real, having an AI actively reading your private emails or digging through your code sounds like a privacy nightmare, right? Well, that's where NVIDIA OpenShell and Deep Windows integration come in. They create a secure, completely private environment, so highly capable agents like Hermes run locally on your own hardware. They sit right there on your Windows taskbar, and your personal data literally never has to leave your device.
Of course, an AI agent is only going to be as useful as the apps it can actually work with. Over the past couple of years, Microsoft and NVIDIA have been pushing hard to build out a massive ecosystem. Heavy hitters like Adobe Photoshop, Premiere, Blender, and even deep technical tools like MATLAB are now either natively optimized for this ARM architecture or they run flawlessly through the Prism emulator. So you aren't leaving any of your essential tools behind. In fact, they're running faster than ever.
For creators, the results are just absolutely transformative. We're talking about a portable laptop that lets you render ultra-large 90GB 3D scenes. You can seamlessly edit 12K video natively. You can generate 4K AI videos locally and run DLSS 4.5 ray reconstruction for real-time neural rendering workflows. It literally redefines what a mobile workstation is even capable of. All right, on to Section 4, Next-Gen Gaming and Creation, Living, Breathing Worlds. Now let's talk about entertainment, because this is where Blackwell's sheer brute force graphics power collides with cutting-edge AI. And the star of the show here is NVIDIA Ace. For decades, video game NPCs have basically just followed rigid, pre-scripted rules. Ace throws that old playbook out the window. It's a suite of AI technologies that turns those static characters into fully autonomous dynamic entities. They aren't just standing around waiting for you to hit a button to talk. They actually perceive their environment, they make plans, and they act on their own. To make these characters actually think like us, they have to be able to perceive the world like us. Ace uses small language models, or SLMs, to process sensory inputs super fast. They use Nemo audio to literally hear and transcribe the sounds around them. They use Nemo vision to physically understand the 3D space they are standing in. And they read the internal game state to apply logic to that world. This constant stream of real-time data lets them make highly realistic decisions right on the fly. The implications for gameplay are just wild. Look at the upcoming game MIR5, for example. Instead of fighting a boss where you just have to memorize a rigid pattern of attacks, you're now fighting an enemy that learns. The AI actually sees your most used strategies, counters your specific spells, and dynamically adapts to how you play. So every single time you face it, the encounter is totally unique. You actually have to adapt your real skills instead of just gaming the system.
And obviously, these highly intelligent characters need to look believable too. That's where RTX Spark accelerates NVIDIA Audio Two-Face. When a real voice actor records lines, or even when the AI generates its own dialogue on the spot, Audio Two-Face instantly and automatically creates the character's facial expressions and matches their lip sync perfectly. It makes the world so much more immersive, and it saves developers thousands of hours of manual animation work.
Now, this isn't just some far-off tech demo. This is a massive shift happening right across the industry as we speak. Starting this fall, RTX Spark is the engine behind a huge wave of Copilot Plus PCs. We're seeing major hardware partners jumping on board, with sleek laptops and ultra-compact desktops rolling out from Microsoft Surface, Asus, Dell, HP, Lenovo, and MSI. The whole PC ecosystem is basically rallying behind this one superchip.
We're truly witnessing a passing of the torch in the computing world. We are officially leaving the '86 past behind, where a computer was just a static tool that you had to micromanage every step of the way. We are stepping into an agentic, ARM-based future. Your PC is now an intelligent, proactive teammate, driven by the RTX Spark Superchip, delivering server-class AI right there on your desk.
Which leaves us with the single most exciting variable in this entire equation: you. With this level of generative AI capability, real-time neural rendering, and truly autonomous agents running securely on your own personal device, when your computer transforms from a passive tool into a proactive teammate, what will you achieve together? Thanks for joining me for this explainer.